Okay, so let's start the webinar. Hi, this is Priya, and I'm from Aarna Networks. Today's webinar is on O-RAN opportunity business advantages. We all thank you for being here with us today. In this webinar, we will learn how the industry is undergoing a profound transformation through open source and standards, 5G, edge computing, AI/ML, and cloud-native approaches that combine powerful economic drivers with rapid innovation. We would love to hear all your queries. However, it would be best if you can keep all your queries for the Q&A session at the end of the webinar. Please pop all your questions in the message box. And if you miss anything, please do not worry. We will be sending you on-demand recording, and also we will publish this in our YouTube channel. So let's go ahead and start. Let me introduce to the speaker for today's webinar. Sriram Rupanagunta, he's a co-founder and SVP at Aarna Networks, and Brandon Wick, Senior Director of Marketing at Aarna Networks. Welcome, Sriram and Brandon.
Thank you very much, Priya.
Yeah. So this is going to be our agenda. And Brandon, you can take over from here.
Yes, certainly. Thank you, Priya.
Thank you.
And thank you for joining us here live today on this webinar on the O-RAN opportunity, business advantages. This is part 2 of a series. Last week, we held a webinar on advanced features and use cases. So if you haven't seen that webinar, I encourage you to consume it. It is on our YouTube channel as well. As Priya said, we'll be packaging up these materials and sending it out to all registrants after the fact. We do want to make this an interactive session there at the end, so please do use the question function, put in your questions, and we'll get to a Q&A at the end. Here's our agenda for today. I'll start off by sort of framing the O-RAN opportunity from a business perspective and from a macro view. Then we'll get into a concept that we call RAN in the cloud. And we'll talk about that and the advantages of this approach and what this approach enables, which is an increasing role of AI in networks by using the RAN, and move into the increasing importance of sustainability in our networks, which can also be enhanced by the RAN. Next slide, please. Okay, everyone here, I'm sure, is familiar with O-RAN. That's why you're here and wanting to learn more, especially around the business side of it. So we won't get into too much detail of the concept, but from our perspective, looking at the advancement of open source, of cloud native, of the proliferation of edge computing with cloud native and 5G, there's been tremendous acceleration in network transformation, especially with greenfield opportunities, but increasingly in brownfield as well. And really one of the last areas, what we're calling the final frontier for this real breakthrough of interoperable, open, disaggregated solutions is around the RAN. So we were extremely pleased, to see the formation of the O-RAN Alliance and other groups a number of years ago, and all the work that's been done to try to make this a reality. And when we look at the tremendous opportunity ahead, both in terms of CapEx and OpEx, the RAN constitutes the largest resource allocation in our mobile networks today, in terms of allocating equipment to be used to support it, and then running that equipment, connecting all these mobile subscribers with high bandwidth services over the network. It's a tremendous cost center, but it's also vastly underutilized because these networks have to be built for peak. And when there's not peak traffic, there's a lot of idle time. And that's really where RAN has an opportunity to shine. But looking at RAN overall, we're really excited about the openness, interop, breaking down vendor lock-in, which we'll get into more a little bit later on. The innovation that comes from working in a community and the different communities around O-RAN, and then the interop that happens at our plug tests and plug fests, and the ability to pull together best of breed solutions from multiple vendors in a way in which will ultimately, in an ideal state, create a solution that's superior than what any one vendor can produce. Next slide. Okay, so until the concept of Open RAN, the old system was very proprietary. I'm sure folks on this call are familiar. It's a similar path that's been taken with software-defined networking and network functions virtualization. Vendor lock-in hinders innovation, brings up costs, and is inflexible. So that's what this opportunity is trying to change. Next slide. Okay, so this led to the O-RAN Alliance. Standards are extremely important in telecom. They've been around there from the beginning. And then even with the rise of open source and open source communities, maybe 10 years ago, to start playing a bigger role in our networks. The first project I'm thinking of is Open Daylight, is now celebrating its 10-year anniversary. But for those two worlds to live side by side, it's sometimes a question of, is it standards or open source? And I think a good way to think about it is it's both. It's yes, and these two are integral and working together to create an environment to foster this innovation and move forward. Next slide. Okay, so I don't want to jump the gun too much on deciding if O-RAN has had a successful run up to this point or not. It's still very much early days, but we now are at the 5-year mark, and I think that's enough time to start looking at what the community has accomplished and the work that's still to come. There's certainly been tangible progress made in O-RAN Alliance, O-RAN Alliance SC, TIP, I14Y Lab, and other initiatives that we're working on and we collaborate with. But there's also, somewhat limited market adoption as of now of O-RAN based solutions instead of proprietary vendor solutions. And so it's certainly too early to say whether it's a success or failure. We'll in a moment, we'll map out some potential directions we think it can go in. But from what I'm hearing, there's definitely, you talk to someone at an event or in our community and they're a naysayer, they emphasize that the performance is not yet good enough compared to other solutions, and that vendors are very well entrenched in this area. And there's a lack of incentives for them to change because of the commercial contracts and bundling of solutions to large customers that just has an inertia of its own. That's hard to break. You also talk to people who are very positive on O-RAN, called the yaysayers, and they point to the historical march of progress of open systems and open source and how transformative that's been for the enterprise and the cloud. And they say it's inevitable that it'll come to the telco space in its entirety, and even to the RAN. And I think the truth is probably somewhere between those two things. And the truth is also what we make it, because working in the communities and working together to pull together solutions is sort of where the rubber meets the road. Next slide. So in general, we don't want to get too much into the predictions game, but looking at where things go from here, I think there's 3 options. Option 1, O-RAN is a failure. I don't think this is feasible really at all, but wanted to put it up there as for our due diligence of what is in the realm of possibilities. Option 2, O-RAN achieves a hollow victory. And by this, I mean, it makes a certain amount of progress in terms of performance and market penetration, but it never gets the inertia and the critical mass needed for mass adoption and breakthroughs and for the network effects to really take place. So, companies could see an advantage on putting a label on their systems as O-RAN compliant, but still push the proprietary stuff. Option 3, which we very much endorse the vision of, is O-RAN being a true success. And what that success looks like is the performance becoming equivalent or better than closed systems, an end-to-end cloud architecture deployed in heterogeneous environments, and working towards multi-vendor deployments as well. And the more RAN components that can be moved into the cloud, the better. That's really what's behind RAN in the cloud, which we'll get into now. Next slide. Okay. So for those unfamiliar with this term, it's really about making sure that the RAN is fully cloudified, or by that we mean being able to be taking advantage of cloud architectures deployed in a true data center, not just a fixed data center, but and really be able to be hosted and run anywhere. So across any cloud or edge environment, hosted really as a multi-tenant cloud infrastructure. And you'll hear us use that word over again, because that's a real sweet spot, I think, for O-RAN and O-RAN proponents. Running containerized cloud native solutions alongside other applications, that's the freedom we need to really innovate new services across the network. And then we can use this to increase the utilization, that number that I talked about, and reduce costs for operators that will hopefully have a life of its own in terms of moving this forward and enabling new services like AI, which we'll get into a little bit later. Next slide. Okay, so a little bit more about RAN in the cloud. Multi-tenancy, multiple services on same infrastructure. This is a key element that will make RAN, sort of the equivalent of the enterprise networks that we're seeing that are run on fully cloud native infrastructure. When you get to the utilization mark, that's going to be key, and we'll talk a little bit more about this from a sustainability fact later on. But this is pointing out that RAN in the cloud, and if you have it fully cloudified, is the only real way to adjust the workloads in order to achieve that utilization. Right now, we're stuck with underutilization, which we think is the main opportunity here in front of us for O-RAN, and the business opportunity when you think of the advantages of services that can be layered on that spare capacity, and also the cost savings from shutting down servers when they're not needed. Next slide. Okay. So we've talked about utilization and running multiple workloads. RAN will become flexible and configurable in those environments. And we'll get into AI a little bit later on, but some of the areas in which underutilization can be taken advantage of, in addition to AI, is running video, content delivery, and more. So this is a big economic factor in terms of savings and also new monetization opportunities. Next slide. Okay, so for here, we want to map these concepts, these business concepts, back to the RAN architecture and talk a little bit more detail about where those are actuated in the architecture. So I'll turn it over to you, Sriram.
Sure. Thanks, Brendan. All right. So this slide basically gives a recap of the O-RAN architecture. So I will not go into a lot of detail because our previous presentations actually covered this in great detail. Essentially, the idea is that all the components are, the O-RAN components are all disaggregated. So each of the box that you see there can potentially come from a different vendor, for example. or a single vendor can support multiple of them. And the key is that the interfaces between them is fully standardized. So, for example, the top box is what's called as a SMO, which we will go into a little more detail now today, which also includes a component called non-real-time rig. And then there is another component called near real-time rig. Again, I'm not going to go into detail of this, but so these are all the pieces that some of them are optional. They may not, all of them may not be needed. The components at the bottom that you see, the OCU, ODU, and ORU. So these are the real RAN elements, centralized unit, distributed unit, and a radio unit. And what is shown here is that they're all running on O-Cloud, what's called as a O-Cloud in the standards. So this is typically any cloud, either on-prem or it could be an edge cloud or in a core data center. It doesn't really matter. It's typically Kubernetes based. It could also be some virtual machine designs. So the standards itself doesn't really say which way you should use. And the arrows that you see from between those boxes are all the interfaces. What is of relevance, at least for today's session, is the interfaces A1 and O1. So these are the ones that that SMO, the top component, uses to communicate with the rest of the RAN elements. Yeah, so again, the purpose of this session is not to go into details of this, but I just wanted to give a recap because the rest of the discussion actually uses this terminology. So I wanted to make sure that you all are familiar with the terminology. Yeah, you can go to the next slide. Yeah, so this gives the kind of the breakdown of all the components. As I mentioned, the SMO, the top box, is what performs the orchestration, management, and automation. So it's kind of a central element which controls all the RAN components. As I mentioned in the previous slide, it also has a component called non-real-time rig, which performs the functions of creating an interface, providing an interface for applications called RApps to run. So, and you'll see some of the examples in the subsequent presentation. But essentially, the idea is that vendors can develop these RApps independent of the platform, and they will enable various applications like optimizing the RAN and any other AML type applications. So they're all run as potentially as RApps. There is another rig component called near real-time rig, which is closer to the RAN elements. So it actually gets the data in a more real time. And even the near real-time rig supports apps, and they're called XApps. So essentially, RApps and XApps are the ones that together provide all of this intelligence in the rig. And rest of the components are essentially the RAN elements. The RU is the physical radio, which is the antenna, the multiple antennas that are in a radio network. And then there are the distributed unit and the centralized unit. And then lastly, the O-Cloud itself, the cloud where all of these containerized or virtual machine elements of these RAN functions are running. And that's the O-Cloud. And again, this is just to give a sort of an overview. I'm not going to go into the detail. Those interested, you can please go through our earlier session, which went into a lot more detail on each of these components and gave a lot more insight into their functionality. Yeah, I can go to the next slide. All right, so now in particular, let's talk about the role of O-RAN SMO. So this is the component that performs the day 0 and the day n functions of all the RAN elements. So that's what is defined as a management and orchestration. And it also performs all the FCAPs, all the configuration, fault management, alerts, performance, software management. So all of them are performed by the O-RAN SMO. So in terms of why it's relevant for what we do at Aarna. So essentially our product AMCOP is a fully functional O-RAN SMO. And that's kind of a natural fit for us because the AMCOP functionality is essentially that. The orchestration, the lifecycle management, and all the service assurance, and which is both open loop and closed loop. So that's the functionality of AMCOP, which essentially fits in nicely with what O-RAN SMO requires. And that's the reason AMCOP is a fully functional O-RAN SMO. Yes, just go to the next slide. All right, so this actually gives an example of a RAN in the cloud that Brandon mentioned earlier. This is actually a real setup that we created, a POC that we created with NVIDIA and Redis and us. So let me briefly explain what this does. And this essentially gives an example of all the concepts that Brandon had mentioned earlier in terms of the utilization and so on. So what you see on the left-hand side is a peak hour scenario where there is an SMO, and then there are two servers running the CU and DU that we just talked about. And then there is a radio components, RU, going through a switch. And there is also a 5G core, which is running on the top server along with SMO. So this is the configuration during the peak hour. Now, what happens is that, let's say during the off-peak hours, the utilization goes down, right? The earlier sort of a fixed function systems, there's no way to do anything about it. If it's running at less capacity, it's running at less capacity, right? So, but here what we do is the SMO actually has ability to scrape for some of the metrics that are going on these servers, which are running the clouds. And based on certain policies, it can migrate for example, let's say the DU2 and CU2 are running at 50% capacity, right? So, which means that you can actually do something else on that server, right? So then what the SMO does is it migrates the DU to the first server. So you can see the red colored box, which is really the DU that's migrated from the server 2. And the CU1, basically serves both the DUs. Now the server 2 gets freed up, and then it can be used for other applications such as edge, some edge applications and so on. So for example, if the servers have GPUs like NVIDIA GPUs, you could use it for other workloads, and the operator can potentially monetize that, right? So this is so the whole purpose is that instead of these servers or the clouds resources sitting idle, you actually run something else on it and then potentially monetize that. And obviously this kind of a thing cannot be done manually, right? So nobody's going to sit at a terminal and then do all of these, because these happen dynamically. And that's where the SMO comes in, where it can do all of these operations using certain policies. So, and again, when it come back to the peak hours, it does exactly the opposite. It again brings down the edge app, and maybe potentially moves it somewhere else, and then brings the DU back onto the other server. So that's the advantage of running all of this in the cloud. because essentially, once you cloudify it, you have the advantage of moving them around and then saving your resources and are utilizing them in a better way. So this gives an example of all the concepts that we talked about in terms of the better utilization and then cloudifying the RAN elements. Right. Yeah, can go to the next slide.
Okay.
So now why don't you take over, Brandon?
Yeah, thank you, Sriram. So let's get into a little bit more of a focus around the role of AI and machine learning. I mean, this could be a webinar to itself or a series of webinars to itself, but we wanted to bring it up here, at least initially, to think about what can be done with the free resources now that are being reallocated through the benefits of RAN. But first, just thinking about AI as a whole and the tremendous impact it's having on our society, on our economy, on our global information ecosystem. We're seeing it across all industries, and it's speeding up, and it's just getting even faster. So it was only 10 years or so ago that it was declared that software is eating the world, and that's certainly proven to be the case. But what's happening now with AI, you have the ability to use AI tools to write software itself. So where there is lack of developer resources and employees, AI is helping to fill that gap and making the deployment of software faster, cheaper, and more omnipresent. So if you look at, from the point of view of a developer, looking at tools like within GitHub, for instance, Copilot, and it's recently been estimated that suggested code via Copilot is making up just under 50% of all code that's now written and inside of GitHub, which is just a tremendous acceleration in just a couple short years. We expect to see more of that, and AI overall to have a disruptive impact. So companies of all shapes and sizes, including ours, are examining all the ways in which AI is having an effect on our business and all the ways in which we can leverage AI in our work to our advantage. So one of those ways, as we've been talking about, is within the networks. This allocation to apply GPU resources away from network connectivity and network services when there's spare capacity and towards AI, we feel is a real game changer. So what we're seeing now, and some folks in this community are very familiar with AI and the insights that it can bring from collecting and analyzing and using that data. And we're going to see an increase in using that at the edge. So collecting, applying, and running these edge applications, these AI applications as well, inside of our networks is going to be a critical business advantage in gaining real-time daily insights on things like network utilization and other types of services. And that's insights that the business leaders of the company can then apply in real time. So AI, can be run anywhere, and it's just these powerful servers at the edge of the networks that need a workload to run will be increasingly running these types of AI applications. And it's our contention that the network operators who are more sophisticated at running AI in those instances will have a competitive advantage against those that don't. Okay, so next slide. And here, Sriram, maybe you can get into your perspective a little more on these next two slides about this question of AI inside the networks as it relates to the apps, R apps, X apps, etc.
Sure. All right. So the first thing is the O-RAN architecture supports these interfaces for running applications. When I showed the picture with all the components, so there are some well-defined interfaces for running, for example, the R apps or X apps, which can be developed by multiple vendors. So essentially, that fosters innovation. And these applications, for example, can do RAN optimizations and handoffs, and so there are various applications that that vendors are developing. So this is one of the areas where the disaggregation and the O-RAN standardization enables people to develop these applications, which are AML centric. And also the RAN data, obviously the RAN networks generate lots of data, which can be pushed into your data lake, and then the MLOps engines can analyze it and provide some insights. So again, our apps can essentially facilitate that. The other sort of a related role for AML is the example that the POC that I just showed, where if the resources are idle, the RAN resources are idle, you can use them for running some AI applications. So these need not be related to the RAN. They may not be R apps or X apps. They could be any other AI applications, except that if they require any specialized hardware like GPUs, the same hardware which is running RAN, during the off-peak hours can run these AI applications. So these are the sort of the two ways that we see where the AML has a role in the O-RAN. So one is for running the RAN applications itself, optimizing them and so on. The other is, you can use other mechanisms to determine whether the resources are fully utilized or not. And if they are not, use them for running any other edge applications, the CDNs and edge AI applications and so on. So these are the roles that we see in terms of its relevance to the O-RAN. Yeah, next slide. Yeah, so in terms of the requirements, right? So now we talked about what are the potential applications and how we could use the cloud for running AML. Now, what do we actually need in order to run them? So the first thing is a general purpose compute with the cloud layer such as Kubernetes, so that these applications can run as a cloud native, easy to develop, easy to migrate. So you get all the advantages of the cloud native applications. And a general purpose acceleration, for example, the NVIDIA GPU, which is what we had used in our POC with NVIDIA and Redis. So this can enable even the non-O-RAN workloads, the AML, Edge IoT, and so on. And then the third one is the software-defined, XHAL, print-haul, backhaul networking. And that's required because when you do all of these types of migrations, you also need to be able to change the underlying network configurations, right? So you require some kind of a software programmability. And then the vendor neutral SMO, which obviously is required because, if the SMO belongs to one of the vendors, then it may not really be flexible enough to be able to move things around and do the kinds of policies that you want them to be flexible. And lastly, the SMO needs the intelligence to understand how the underlying network is being utilized, which is the example that we showed in the POC, where the SMO monitors the metrics of the underlying network and then takes actions based on that. So essentially, you need all of these in order to enable the AML in the O-RAN. And of course, if you don't have some of them, you can still use it with certain restrictions. But this is what we see as a requirement to fully utilize the underlying cloud infrastructure and use it for AML. Yeah, the next slide. Yeah, back to you.
All right, thanks, Sriram. So now I want to touch briefly on sustainability. So in addition to allocating spare resources to running AI applications, the network operator also has the chance to allocate or disconnect or power down is probably a better word, commercial off-the-shelf servers that are not actively being needed to support services during off-peak hours. So RAN gives you the ability to do this. And we find that networks that don't take advantage of this, that aren't dynamic and agile with their resource allocations, are wasting a lot of energy. This conversation is now heating up, and we've encountered many folks, especially over the past few months, and especially in Europe, talking about the importance of sustainability. It's no longer a nice to have, but it's a need to have. And here are some of the areas that are top of mind for the industry. Took this photo at an industry event, and this is a look at what VMware is working on and thinking about as it relates to sustainability. And I think this rings true for almost everyone in the industry. And as it relates to our topic here today, the virtualization, the automation, and the workload placement are very important. When you look at the ability to power down or cycle down a bare metal server when not needed, that's a considerable source of energy and electricity that's saved. Next slide. And here's a chart that I want to show because this topic is becoming increasingly important in these times of uncertainty. So just over the last 2 years, from January 2021, this is a look at producer and consumer energy prices in Europe and the uncertainty that was caused by the start of the war in Ukraine. So you have swings in energy prices and a steady climb of those electricity prices. I think they've come down a little bit recently, but it was a real wake-up call for European economies as they look to reallocate the source of their energy, how that was affecting electricity prices. And for all of the networks out there that are really power hungry, electricity hungry, they're taking a big hit when there are rapid and unforeseen price swings or prolonged periods of high prices, which makes the ability to do the resource allocation that RAN promises even more important. Okay, next slide. All right, so here we are trying to do some calculation and produce some metrics. We're working with some stats that we've discovered at the NVIDIA GTC conference. In fact, last year, we're talking with the presenter there, Chris Lamb, who's pointing out that it's estimated that maybe 60% of public 5G cost is in the RAN itself. Then that's where we get the figure around it being the majority of network costs. And then when we apply that to a utilization figure, and we're using a conservative one, I think, between 25 to 30% utilization. When you combine those two together, you get an idea that just under half of the total network capacity is not currently being utilized or is being wasted. And that's I think the overall sense and number that we have to work within on how we reallocate that to either value-added services like AI or video or CDN at the edge, or the cycling down of unnecessary allocations to save on power costs. All right, so back over to you, Sriram, and your thoughts on O-RAN and sustainability.
So here are some of the factors that we believe which can lend themselves to the sustainability and the energy efficiency in the context of the O-RAN, disaggregated O-RAN. So first thing is, instead of using specialized hardware, now we are going to be largely using the off-the-shelf servers for running majority of the functionality. And of course, there is still some hardware, such as radios, which you cannot virtualize, but everything else pretty much can run in software. And it doesn't require any specialized hardware as such, unless you want to do some GPU type things. But in general, it's off-the-shelf servers, so you can save on the power consumption. So that's one of the factors. The second one is a better utilization. I think the whole example that we gave, that we showed in this, where you can use them to run other workloads during the off-peak hours. So that obviously saves a lot of energy, because earlier you would have required another set of servers for resources for running that. The third is obviously the virtualization of the component itself, instead of running them as specialized hardware, which is kind of related to the first point. And lastly, by containerizing them or running them as VM workloads, it's a lot easier to scale up, scale down as needed. Because earlier you would have had to probably add a new box when you're running near the capacity, but now it's a matter of just scaling out your containers and getting more capacity. So all of these factors will lend themselves to better energy efficiency in our opinion. Yeah, back to you.
Thank you, Sriram. And we were targeting 45 minutes for our presentation, and we're right on time. So kudos for that. All right, so that brings us to the end of our presentation portion of the webinar. I'll go through a couple questions now that have come in. Feel free to add any more questions. We can get to those here as time allows. So the first one is around performance. How far away is performance parity of O-RAN stacks with proprietary vendor stacks? So I don't know that one in detail. I know it's improving over time, but I don't know, Sriram, if you have any general thoughts on that.
So I think it's probably a little bit early to get some real hard numbers. But I think the trend that we are seeing is that things are getting better over time. Obviously there is still some disparity in terms of the performance, but what we see is that as more and more vendors start building components in the disaggregated manner, and more interrupt testing happens using the TIP Roma and I14Y type of labs, we see that the trend is that things are getting better.
Okay. All right, what do we see as the major obstacles remaining to O-RAN adoption? And that's kind of a big one. So maybe I'll just highlight a couple of things that popped to mind for me. I think the main challenges right now in terms of aligning the ecosystem is that the incentives are not yet fully aligned. You have two different streams of sales and revenue generation into the big operators and customers, and O-RAN is just a trickle in that flow as of now. So attention, priority, resources will be on the revenue generating activities, and that's a little hard to break. So there's some inertia there that needs to be overcome. The interop testing environments, they're still maturing. We're a long way from universal interop. It'll get there in stages. I think the further we go with releases from the O-RAN Alliance SC, the more testing that gets done in these initiatives, the more use cases that are proven out with tangible results, and then the more that the network operators who are building these systems demand O-RAN, the more that the vendor community and the third-party application community will respond to that. Your thoughts, Sriram, on challenges and how to overcome them?
Yeah, I think you kind of hit upon the main ones. I think the interop is really the biggest challenge, because by nature it's all disaggregated, so potentially different vendors can provide different components. So obviously the end customer, the operator, or the enterprise that's using it wants to make sure that everything works together. So that's going to be the biggest challenge. And I think there are enough initiatives that have started to address that. And the other one is, of course, the performance, which we just talked about earlier. And I think these are the main issues that the main challenges at the moment.
Okay, sounds good. All right, I think that's it for questions as of now. Give a moment for any other final questions to come in. And seeing none, I think we can go ahead and wrap up. Well, thank you very much, Priya. Thank you, Sriram. Enjoyed presenting on this topic here today. Want to invite all of our webinar participants to please stay engaged with us on this topic. We're very interested, very motivated, and working hard in our communities to make O-RAN a reality for the industry and making it successful. So thank you all, and we'll talk again soon.
Yeah, thank you, Brendan. Thank you, Sriram. Thank you. See you all.
Okay, bye-bye.
Bye-bye.
Bye.